Today we're going to take a look at multiple linear regression. This means that we are using multiple x variables to predict our y variable. In this case, we're looking at some housing data from California in 2014. So we have the price of some houses, the square foot of living space, and the year in which the house was built. Before we can do our multiple linear regression, we have to make a few assumptions. First, we are assuming that there is a linear relationship between each individual x variable and the y variable. So we're assuming that the relationship between square foot of living space and price is approximately linear, and the relationship between year built and the price is approximately linear. We are also assuming that there is not a strong correlation between square foot of living space and year built, so your x variables. Assuming those things, we are going to get a function that is in this format. So we have slope times our first x variable plus slope times our second x variable plus our y-intercept. And you can expand this to do more than two x variables. It would be the exact same setup. So I'm going to assume that both size of the house, square foot of living space, and age of the house, the year it was built, affect the price of the house. So when I start typing my formula, I have ln est, then I highlight my y variable, which is the price. I will tell you, if you click on the A at the top, it's not going to work out correctly. You do, unfortunately, have to highlight all of the numbers. Then you want to highlight all of your x variables. So I'm going to highlight both columns B and C. And it's going to output some numbers. It outputs the numbers in this order. The first number is slope 2. Second number is slope 1. The third number is your y-intercept. If you had more than two x variables, it would be in the same format. It's going to start with the slope of your last x variable, continue to the slope of your first x variable, and then end with your y-intercept. So this slope goes with year built, this slope goes with square foot of living, and this is your y-intercept. So you can use these numbers to make predictions the same way that you did with a regular linear regression. So if I assume x1, my first x variable is square foot of living space. Let's say I have a house, 800 square feet, that was built in 1995. And I want to predict the cost of this house. So I have, following this formula that I have in cell E1, I have M1 times X1 plus M2 times X2 plus B. So this equation estimates that a house with 800 square feet built in 1995 would have cost $154,000 in whatever zip code this was in 2014. If you want to get the r-squared value, like we did for regular linear regression, you're going to go back in here to your ln est formula and add comma true, comma true. Now, it does not like how close my x values are in here, so I'm going to move this data down a little bit so that that can expand. Your r-squared value is going to be this number in the first column of the third row. So you can see there's not a particularly strong relationship here, but do with that what you want. So that's how you do multiple linear regression.